Okay, chapter 16 has to do with acid-base equilibria. This is, if you recall, when we were talking about chapter 14, I said we're skipping 15 and coming back to it in 16. So this is the same equilibria that we did back in chapter 16, or chapter 14, I should say. It's just the fact we're now applying it to an acid. We did that in chapter 15 with the KW. Okay. So, so basically, oops, I said I want to use that, and then I didn't. Okay. So Kc, we're going to be using Ka, and the A means weak acid. So it's still going to be, the equilibrium constant is now Ka, and it's the concentrations of the products raised to any coefficients divided by the concentration of the reactants, also raised to any coefficients. And the other rule to remember is no liquids or solids. Okay. So acid ionization is when I put an acid into water and it forms a hydronium ion. And again, as a review from last chapter, hydronium means H3O plus. And the conjugate base, which is the conjugate base is the same as the acid but without a hydrogen. So this is a generic equation. So this simply means a weak acid, any weak acid. So if you don't know the formula of the acid that they say and they don't give you the formula, just simply use WA. It doesn't affect how you work the problem. So you add a weak acid to water. In equilibrium, it forms the hydronium ion plus the acid without the hydrogen. So the A is the same A. Change colors here. This is the same A here. It's just the fact we lost the hydrogen. Now, when I tend to write these in reverse. I tend to write the A minus first and then the hydronium. That's all up to you. But it's the concentration of the hydronium ion times the conjugate base over the weak acid. Why is there no water? Because you notice that I do have water as a reactant here. Okay. But it's not listed in my Ka expression. And the simpler reason is the fact that it's a liquid. Okay. So, no water. Because it's a liquid. Okay. We are going to add one new thing to this, which is the, we're also going to be doing, I should say, the determination of Ka, okay? But we're adding something called the degree of ionization, which I abbreviate because that's a lot of writing right there. I abbreviate it as DOI for degree of ionization. The formula for degree of ionization is the hydronium ion concentration at equilibrium over the weak acid concentration initially at 0. And so that fraction tells you how strong an acid is. So the larger this number is, the stronger the acid, the more of the product it produced over the less of the reactant that's still there. The lower the number, the weaker the acid. Okay, so higher DOI, stronger acids. And so the opposite is also true. A lower DOI is a weaker acid. Okay, so let's just start doing these. This one wants you to write the chemical equations. I'm going to add to that. We're also going to write the Ka expression for this also. So this is typical. It gives you a formula and asks you to write the acid ionization. So I start out by taking the acid plus water. So I'm going to always add to water. My equilibrium, which is 2 reaction arrows. Like I said, I tend to write HA or A minus first. So basically A comes from, if I were to divide this, okay, so there's my hydrogen. Okay, so I'm going to, this is the H that goes over here, and this is all A from that previous slide. So I have CO2H, and we practiced in the last chapter in the Alex homework, or in the homework section, about the fact that to write the conjugate base, if it's neutral, it becomes more negative. Okay, and then so this hydrogen here goes to join with the water, so it goes to form the hydronium ion. So this is my A, and this is going to be my hydronium. And then to write the Ka for this expression, it's going to be the CO2H minus times H3O plus divided by the HCO2H. Okay, and again, no water because water is a liquid. Okay, I would stop the video and try to do these next two on your own, but then I'm going to walk through them. Okay, so I have HN3 plus water, the double arrows. My A is just going to be my N3. Oops. Not N3 minus N3 with a negative. Plus the H3O plus. And then the Ka expression for this is going to be the N3 minus times H3O plus divided by HN3. Okay. And the last one is the HOCN plus water. Goes to form OCN minus plus H3O plus with a Ka of OCN minus times H3O plus divided by HOCN. Okay? That will be the end of this video.